All right, we are live. Give everybody a couple minutes to jump in here. But while we're waiting, I want to remind everybody that tomorrow we have a super exciting live stream planned. From 1 o'clock to 2 o'clock, Dr. Sarah Perry is going to be joining us. She's going to be talking about her experience going through college level chemistry, and she's also going to be answering your questions. So, a lot of you I know are going to be taking chemistry in college. This is an opportunity for you to talk to an actual, legitimate chemistry teacher, chemistry professor, about what to expect. Like, is high school chemistry as difficult as college chemistry, or whatever questions you can come up with. So, right now, what I want you to do while we're waiting for everybody to jump in is think of some questions that you might have for her. And I'm going to be jotting these down. And if you can't join us tomorrow for the live stream, I will ask the questions for you. And then maybe what I'll do is, obviously the live stream is going to be published to YouTube, but maybe I'll take all of her responses and kind of condense them into like a document so you can look at them if you don't want to watch the whole thing. So it looks like Adriana's here. Hello. How are you doing today? Did you do anything fun this morning, other than school, of course? I got one of my wife's color-changing cups here. CoolestDentistEver.com. Any questions you can think of for Dr. Perry? Looks like I've got a couple of you guys in here right now, waiting for a few others to pop in. If we only have a couple, that's fine. We will just continue on. So today's plan is to do a little bit of review. Nice. I'm glad you think it's boring. Okay. You don't have to stay here. You can go through the Kahoot. The Kahoot is all we had to do for review today. I don't have much work. That's good that your other teachers are being nice and not piling it on while you guys are on break. All right. So give everybody about 2 more minutes, and then we'll get started with the review for today. So nobody has any questions you can think of. Adriana and Jocelyn, I know that you're in here. Do you know what you're going to do for college? Are you going to a school, or are you going into a program where you have to take chemistry in college? There's a little bit of a delay, I think, here for the chat, but that's okay. Put music on or something in the background. What do you want to jam out to? Let me see what I got. Hey, Aran, how are you doing? Gonna be a music teacher. Probably not gonna need chemistry for music teacher, but you never know. Maybe you can come up with some. I'm not going to college. Ew, Jocelyn, what are you gonna do then? What's your plan? I'm gonna find my favorite song here. It is the best. I'm just gonna go ahead and play it. I think this is the right one. Hey,
Shell.
Tacos, like the best song ever.
Lettuce, cheese, shell, meat, lettuce.
You heard this song? It's like the best.
Cheese, 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 cheese.
It's raining tacos.
Can you hear that?
Raining tacos. Raining tacos.
I really could go for some tacos right now.
It's raining tacos.
Alright, that's enough of that. So, were you guys able to hear that sound? Alright, let's get started. We're waiting for a couple other people to pop in, but I don't want to wait the entire time, so let's jump into it. So I had a question yesterday. I think Caesar was the one that asked this question. He said we were talking about circuits, and he asked the question because we were talking about how circuit breakers have a 15 to 20 amp limit. He asked why 20? Why don't we have anything that does anything that handles a larger current? Okay, and I did a little bit of research, and I couldn't quite find a clear answer, but the one that I found is it has to do with the design of the receptacles. So, like, washers and dryers sometimes use the 220s, which draw more current, and the design of those plugs are a little bit different. So it sounds like it has to do with the actual physical design of the plugs. So that sounds like the answer. Okay, but I have a friend that's an electrician, and I'm going to ask and see if I can get a better answer. But as of right now, it sounds like it's a design issue. Obviously, this isn't on the test. All right, so let's talk about tomorrow. It looks like Heaven just jumped in. Hey, Heaven. All right, so tomorrow you do have a quiz. It's going to be an open note quiz, and it's going to basically just cover the basics of a circuit. So, like what's a battery, what's a switch, what's a resistor kind of stuff, and there will be a couple of Ohm's Law problems. You do need to know the difference between series and parallel circuits, which hopefully by now you've gotten enough experience with that. If you haven't, go back and watch the notes. But that was why I wanted to cover those before we left, because the types of circuits, series and parallel, can be a little tricky. So, yeah. Now, as promised, you guys were asking for like a tour of my house, and I said every day I would show you a little bit more. So here is a video. You haven't met my cat yet, so here is my cat, Kitten. This is my cat, Kitten. Just kind of sunbathing here. Must be nice to be a cat. You have no idea what's going on in the outside world right now. World's pretty much ending, and you're just kind of here chilling. Totally jealous of you. Cat also doesn't have to go to work. All right, so let's quickly jump in and review quickly what we've been talking about. So these are things you need to know for the quiz tomorrow. You need to know what voltage is, what current is, what resistance is. Just really basic. Voltage is what pushes it through. Yeah, you need to catch up on the notes a little bit, Heaven. Voltage is what pushes everything through. Current is the flow, and then resistance is easy to remember because you all are familiar with the word resistance. Resistance is just restricting the flow. So again, think about going the opposite direction that current's flowing in a river, how you feel that pushback. That's kind of what a resistor does. It resists the flow. All right. And then Ohm's Law. You should be familiar with the triangle and how to use it. So if you're solving for voltage, you cover up the V in the triangle, and then it's just I times R. If you're solving for resistance, you cover up the R on the triangle, and it's voltage over current. You'll have all the formulas and everything when you go to take the test. But you just need to know the basics of how to solve that. All right. So for today, what I'd like you to do, we're going to just do some practice problems, very similar to what you might see tomorrow in the quiz. So what I'd like you to grab really quick is a calculator. Your phone will work just fine. None of the math we're doing in this is super complicated where you're going to want a scientific calculator. Just regular addition, subtraction, multiplication, division is fine on your calculator. A pencil and some scratch paper. And then as we're going through these practice problems, I will put the formulas up that you'll need. So you don't have to pull out your notes or anything unless you want to look. All right. So while you're getting ready, I'm going to go ahead and pull up the review on my OneNote here. And I will put this out on the page for today's assignment that you went to for the Kahoot. So if you want to go through and look at these later, you can. Okay? So let me make this a little bit bigger. And let's get rolling here. All right, so I'd like you to try to work through these with me if you can. And then I'll just have you type the answers into the... I'm not starting yet, Heaven. Calm down. Jeez. I'd like you to just type the answers in the chat if you could. So my first question here says find the voltage of a circuit with a 20 amps of current and a resistance of 100. Okay, so we're finding the voltage. So on our triangle, you are finding the V. Okay, so on the triangle, it's just going to be I times R. So let's write this out. So voltage equals current times resistance. Right? And if we're filling in this in, current is 20 amps. And the resistance is 100 ohms. So go ahead and do that in your calculator. 20 times 100. And here's my calculator. Anybody got it? I have a sticky note right here, and I'm going to write your name on this and try not to lose it. So when we do go back to school, I will give you candy for getting the right answer and participating. Or maybe I'll give you one of these awesome color-changing cups that my wife has for her dental practice. See this? coolestdentistever.com. 20 times 100. Who's got it? You know what I should do instead of candy? I should maybe send you toilet paper, because everybody's out of toilet paper right now. Anybody got an answer? I'm just going to go ahead and... Maybe you guys are just watching me. Nobody's actually doing anything. Just like normal class. Thank you, Adriana. I'm going to write your name down on this sticky note. Oh, and Anahi chimed in. Adriana, you were the first one. Oh, now you're all chiming in. Okay, maybe there was a little delay. All right, so the answer is 2,000. Voltage, the units are volts. That's easy to remember. So there's our first one. Let's move on to the second practice problem here. All right, so for the second one, it says find the current of a 110 volt circuit with 200 ohms of resistance. This is not in your notes, Jocelyn. These are practice problems. I'll put these up later. If you just want to work them out on scratch paper, pretend like we're whiteboarding like we would do in school. We just don't have whiteboards at home, unless you're cool and maybe you have one. I don't know. I don't have one. All right, so let's set this up. So we're finding the current, which is I. So on our triangle here, if we're solving for I, it's going to be voltage over resistance. Okay, so our voltage is 110 volts. And the resistance is, sorry, it's 110, not 100. And the resistance is 200 ohms. So 110 divided by 200, and Heaven, yes, you got to be a little quicker to get candy. You got to be the first one. Should have that calculator like ready to go. So 110 divided by 200. First one to chime in gets candy. If we ever see each other ever again, I will give you candy or toilet paper. You know what's a really hot item right now is meat. None of the stores have any meat. Good time to be a vegetarian. Although, we're going to probably run out of vegetables. Jocelyn, let's see, I think you're right. 110 divided by 200 is, yes, 0.55. Jocelyn, you are correct, as is everybody else that typed their answer in. When we go to do current, current is the only one that's kind of tricky. Current, the units are amps. So even though current starts with the letter C, amp starts with the letter A, it's kind of hard to remember. Adriana, I got your name down on the sticky, don't worry. I'll get you. I got you. All right, here's the next one. Find the resistance of a 1,000 volt circuit with 50 amps of current. So why don't you take a minute and try to do this one on your own, and then I'll go through it. While you're doing that, I'm going to look out the window and think about stuff. I don't know. I got nothing. It's always awkward in school when I give you guys something to work on, and then I just kind of walk around, but there's nowhere to walk around here. Jocelyn. All right, so when you've got the answer, go ahead and type it in the chat. All right, looks like we got a couple answers, so I'm going to start to work through this. So the resistance, if you're looking at the triangle, resistance is R, so we cover that up, and it's going to be voltage over current. So our voltage is 1,000 volts. The current is 50 amps. 50 divided by 1,000 is, bro, I'm finna get mad. I don't know what to tell you. Maybe I'll just give everybody candy when I come back. All right, the resistance is 20 ohms. Heaven, I don't want you to get mad. All right, that's number 3. All right, here we go. This one's a little trickier. This is like kind of what we did yesterday. So it says, assuming the current remains constant, how is voltage affected when resistance is tripled? Okay, so we want to know how voltage is affected. So we're looking at voltage. So V equals I times R. All right, and we are tripling resistance. So mathematically, if I wanted to write that out, I would triple resistance. So I'm going to put a 3 in front of my resistance. So it will be written out like this. 3 times R. So if I'm tripling the resistance, what I do to one side, I have to do to the other. So it's going to triple the voltage. So what I do to one side, I have to do to the other. And just think about that, okay? So I said that think of voltage as kind of like the pressure, right? And if you are, yeah, exactly. Yeah, if you've got a tube and you are increasing the resistance, you're making it harder for things to flow through there. You got to apply more pressure for the flow to maintain the same rate. Okay, so you have to apply more pressure. Like if the river's getting, if the river's faster, it's fighting you more. You have to apply more pressure to move forward. If that makes any sense. Okay. All right. Let's look at the next one. Assuming the resistance remains constant, how is voltage affected when current is halved? Current is halved. Okay, so I'll give you a second or two to start this one on your own, and then we'll go through it. Oh, my cats are being adorable right now. They are sitting next to each other looking out the window. I don't know how I can show you that. Let me see if I take a picture and I can pop it up on the screen. I'm not using my phone during school, don't worry. Upload. Voltage is halved. All right, Lily, let's see. So how is the voltage affected when current is halved? So again, we're finding voltage, so V equals I times R. If we're having the current, so current divided by 2, that means our voltage also has to be divided by 2. So our voltage would be halved. Nice job, Lily. And heaven. And heaven. Good work. All right, number 6. Okay, this one you're going to kind of have to do on your own paper here. All right, you're not going to be able to type this into the chat, but I want you to draw a series circuit that contains a battery, a switch, and a light bulb, and we'll represent the light bulb as a resistor. So it's a series circuit. Why don't we do this one together? All right, so it's a series circuit. So remember, the series circuit has to be a loop. Okay, so one path for everything to take. So we've got our battery, which looks like that, and then it says a switch and a light bulb. So remember, our switch looks like this, and then a light bulb as a resistor would be this. All right. You don't have to draw a circuit on a test. You just need to be able to look at a circuit. So this is probably harder than what you'd have to do. But again, here are all the components. We've got our battery or our power supply. Here is our switch. And here is our resistor. Okay? Easy enough, right? Why don't you guys try this one? So this is a parallel circuit, and I'll give you a little hint to get you started on this one. Remember, parallel circuits have different branches. So a series circuit looks like this. A parallel circuit with 2 branches would look like this. Okay, because you've got a branch here you can go down, and you've got a branch here that you can go down. What would a parallel circuit look like with 3 branches? Okay, and each branch should have its own resistor. Remember, resistor looks like that. So try drawing that out, and while you're doing that, I'm going to see if I can pull this cat picture up. They're just sitting there. They have no idea what's going on in the outside world. Ignorance is bliss. All right, let's see here. Oh, all right, let's check this out. These are my cats right now. I just snapped this picture. Right? Tell me that's not the most adorable thing you've ever seen. They're sitting together looking out the window and just taking it in. All right, let me pull the OneNote back up. Okay, so I'm going to start to work through this one. So a parallel circuit that contains a battery, 3 branches, and a resistor for each branch. So here's my battery, and this would be a series circuit, but I want to have 3 branches. So here's 2 branches. Here is 3 branches. Heaven, what have you been learning over the past few days? All right, so now I'm going to put a resistor on each branch. So for the first one, there's one resistor. For the second branch, here's another resistor. And for the third branch, whoops, there goes my whole circuit. Just like that, okay? So as the electricity is flowing, as we're going this way, when it gets to this point, it's got two paths it can take. It can go this way or it can go this way, right? So the electricity keeps flowing. So let's say it went this way. And again, you've got another path for the electricity to take when it gets to this point. It can go this way or it can go this way. And keeps going. And at this point, there's only one path to go, okay? So one of the advantages, remember, of a parallel circuit over a series circuit is that if this light bulb goes out, there are still other paths for the electricity to take. Okay, so this light bulb here and this light bulb here would continue to work. So that's the advantage of a parallel circuit. Now, if we go back up to the series circuit, if something were to happen with this light bulb right here, this resistor, if something were to happen to that light bulb, the whole circuit goes out. So they used to make holiday lights or Christmas lights. They used to be done in series, and one of the light bulbs would go out, and all of the light bulbs would stop working. So imagine having to go through the entire strand of lights to find which one was bad, replace it. It was probably just terrible. People were probably like cursing, and it was just ruining the holidays for everybody. So not good. All right. So I think I had one more, and this is tough. We can talk about this one here. So the question is this a series or a parallel circuit, and how do you know? So what do you guys think? Is this a series or a parallel circuit, and how do you know? So take a look at the circuit and think about it. Anybody want to chime in the chat? Nice timing. Got to be the first one, right? We are going to have so much fun in chemistry today, you have no idea. So is this a series or a parallel circuit, and how do you know? Diamond, you want to chime in on this? Feel free. Series or parallel? Anybody? This one's kind of weird, right? Or is this a trick question? Because I'm always trying to trick you guys, right? This is a series or parallel circuit. Better not be Googling the answer. Even though you have access to Google at home and I can't watch you, don't do it. I can tell that the amount of effort we have left at this point in the day is non-existent. This is just like regular class. You forgot how to do physics. All right, so Heaven says it's parallel because it has more branches. Okay, that's good. I do see multiple branches here, so when you get to this point in the circuit, you've got a branch to the right and you've got a branch to the left here. All right, same thing down at the bottom. You've got a branch here and a branch here. But let me ask you a question. What do you think would happen if the circuit broke right here? Okay, so something happened to the circuit right there and the circuit broke. Would we still, like if these were light bulbs, would these still work? Or would they stop working? The answer is they would stop working. Okay, so this is kind of a trick question. This is actually a combination circuit. So it's a series circuit, but it has parallel circuits within the series circuit. So on the outside, so on this part right here, this is a series circuit, right? But on the inside, this part right here is a parallel circuit. So if one of these if this resistor if something happened to this resistor right here, this other one would continue to work, and vice versa. If this one went out, this one would continue to work. All right, so it provides multiple paths within the circuit. Now, if you look outside the parallel circuit, there's nothing else here. So this is just two parallel circuits kind of nested within a series circuit. Okay, you were going to say that. You're capping. You're totally capping right now. There's nobody here to yell at me for saying that. All right. I think that was it. So, did you guys have any other questions about either the Ohm's law questions or the circuits in general? Because when you take your quiz tomorrow, it is going to be open notes. But if there's something you don't understand, like I know Heaven, you said you haven't been really doing anything for the last couple days, which is fair. I mean, I get the world's ending, so who really wants to focus on school right now? I get that, but still got to do it. So what questions do you guys have? Anything? The world's not really ending. I'm just kidding. Everybody in the news says it is, though, but don't worry. If everything just goes south, you guys just come over to my house, and we'll have a big party. Big end-of-the-world party. I haven't asked my wife, but I'm sure she'd be on board with that. A big party, end of the world. All right. Well, if you guys don't have any other questions, let me pull this back up. If you guys don't have any other questions, I just want to remind you that you do have a quiz tomorrow. There is a Kahoot that I put on. People are actually doing their work. I'm impressed. More so physics than chemistry. Chemistry, we're going to have a heart-to-heart about the amount of work that they're actually putting forth. Okay, but physics, you guys are doing great. So there is a Kahoot, and Jocelyn was actually the one that emailed me to tell me that there was an issue with the post. And when I posted the Kahoot this morning, or actually it was last night, I have it scheduled to go live at 9 a.m. I put 9 p.m. instead of 9 a.m., so it didn't post right. So I think what I'm going to do is I'm going to have it set up to post at like 12:01 a.m. so it's there right away for you guys from now on. There's no reason to have it post at 9 a.m. because I've been doing everything the night before. So if you haven't done so already, please play through the Kahoot. It's only 20 questions, and there's very little math. So the quiz is tomorrow. It's open notes. Hey, Denasia, how are you? Our unit exam is going to be, I know you were mad, I'm sorry. The unit exam is going to be after spring break, okay? So it's going to be pretty short test, and I get that you guys are at home. You're not going to be able to take the test, obviously, in Master Manager because, there's no point. You guys are at home. You can call people. You can look at your notes. I get that. So it's going to be an open notes test. All of the physics teachers, we've kind of worked together to create an open notes test that you can do. So there'll still be a little bit of challenge, but you'll be able to use your notes. Now, we will review Monday when you guys get back from spring break. And then, of course, like I said, the exam will be open notes. Okay. Tomorrow we do have, again, Dr. Perry. She's going to be joining us. So there won't be any actual physics lesson tomorrow during the live chat. But if you guys are able to join me tomorrow afternoon at 1 o'clock from 1 to 2, she's going to be on. I'm going to be Skyping with her. So you'll be able to see her and me at the same time. And you'll be able to ask her questions through the chat. And yeah, it should be awesome. She's a good friend of mine. I've known her for a long time. She and I used to do Taekwondo together. So I don't know if I've actually fought her personally, but we've done Taekwondo together. So she's really cool, super smart, and I'm really excited that she's going to be able to Skype with us tomorrow. So if you guys have any questions, I did send you a Microsoft form that you can fill your questions in. I'd like to get questions from you in advance, so that way I can kind of put them together in an order, and I want to make sure that I'm able to ask all of your questions if you're not able to be there tomorrow. Okay? So please send me your questions. If you can't think of any now, that's fine. If you do join us, you'll be able to type your questions in the chat, and she'll respond to those. Okay? So unless you guys have any other questions, I'm going to go ahead and pivot to chemistry at this point. So you're welcome to stick around and learn some chemistry, but otherwise I will see you guys tomorrow. So chemistry. So Diamond, Denasia, is there anybody else here from chemistry right now? Diamond, I miss school too. My kids are driving me absolutely crazy. My son this morning threw a huge fit because he doesn't think that he should have to do any schoolwork. He thinks that he should just play Fortnite all day long, like literally the entire day, from the time he wakes up until the time he goes to bed. And he's been super moody about it. So, yeah, being a parent is not fun sometimes, let me tell you. All right. So, anybody else from chemistry here? If not, that's fine. What I'm going to do is go through some sample calculations for the lab that you guys are working on. and that's pretty much the plan for today. If you guys have any other questions about who's your sister? I don't know who you're talking about. Dude, that's my sister. Diamond, don't be stressed. Don't be stressed. I'm dead. I don't know what you're talking about. All right, so let's get rolling here. Do you guys have any questions about... Denasia, you hate everything. You say you hate school, you hate e-learning. What do you like? Like your job? Is your job fun? You get to actually go out and see actual people. Oh, I get it. Your sister wants to play Fortnite instead of schoolwork. I mean, there are definitely things that I would rather be doing instead of school right now. It's tempting when you're home, but if you fall into that trap, it's bad news. Like, it's like a time machine. Like, you're playing your game, and like all of a sudden, like 8 hours go by. So I get that. So I honestly, I'm being completely honest with you guys. I've been home this entire time, and all I've been doing has been getting stuff ready for school. I've been trying to get stuff graded, trying to get caught up on grading, and then dealing with my kids. That's it. I haven't played any games. None. I haven't even watched a TV show yet. Which, if you're a Star Trek fan, the new episode of Picard dropped today, so I'm going to be definitely watching that tonight. All right, so let's go through the lab calculations. If you guys don't have any questions. I don't get anything for the lab. Great. Well, you're in the right place because I'm going to go through it all right now. So let me pull up my OneNote, and I'm going to go through some sample calculations. All right. Now, everybody in chemistry has a unique set of data. Okay, because if I had given you guys all the same data, there would be all sorts of copying and stuff going on. So I want you to be able to work together on this, but you're going to you're just going to be using your data. That's totally fine if you want to work with somebody else. Just know that you're not going to get the same answer as them. Okay, so I'm going to work through the calculations, and these are almost identical to what we've been doing over the last couple days. So I have my calculation, or I've got my data page pulled up on my OneNote. If you want to kind of listen to me in the background, or even maybe split screen it so you can work through yours at the same time, or maybe pull out another piece of paper and do it on a piece of paper, that's fine. But I'm going to walk through how to do all of this so it's not overwhelming, because it's hard to do when you don't have someone there to ask questions. So I had unknown number 30. No one else has unknown number 30. And in the video for today, I told you that you're only doing one trial. So for trial number 2, I'm going to go ahead and cross off that column because we don't do that. And then I'm going to fill in what I've got. Okay, so on your data table, you're going to fill in the numbers that you were given from the data. So the mass of my piece of metal was 12.1 grams. The mass of water was 100 grams. The initial temperature of water was 21.5. The initial temperature of the metal was 100. And the equilibrium temperature, so the final temperature of both the metal and the water, was 23.5. Okay. Before I move on, is there anybody that doesn't know where they're supposed to look for their data or doesn't understand where the numbers are coming from? Because I'm happy to pull up the data and show you. I want to make sure we're all on the same page before I go further. So I'll pause for a second. Aren't these color changing cups like the best? Look at this. It's one of my wife's cups from her dental practice, which isn't open right now. Like, nothing's open. Not even Chuck E. Cheese. Super sad about that. I love Chuck E. Cheese. Repeat it, please. Sure. So all we're doing right now is I'm using a sample set of data, and I'm writing in I'm basically transferring my data set from the data that I gave you guys to my sheet. So let me just quickly show you, just in case there's somebody out there that's maybe afraid to ask. So on here, let me go to my website. All right, so it's under eLearning, chemistry, and then depending on which class you're in. So it's either period 6 or period 8. You click on that. I'll use period 8, and then you should get this. Okay, so within here, you just find your name on the list. It's got the unknown number, the mass of the metal, the mass of the water, the specific heat of the water, the initial temperature of the metal, the initial temperature of the water, and then the final temperature of the water and the metal. So I'm just taking those numbers and I'm transferring them to my data table on OneNote. Okay. Now, if you were actually doing the lab in class, you would have been writing this down during the lab as you did it. Okay, but obviously you're not doing the lab. You're doing it from a set of data. Okay, so let's keep going. So for the calculations. Okay, Denasia says, wait! So I'll hold on a second. I don't know which data to take. So your name is on there. So if you go to, oh, you got it. Okay, yeah, I was going to say your name is on it. So you're in period 6. So if you click on period 6, you have unknown number 8. Yeah, okay, cool. So everybody's got their data. So you're just transferring your numbers to the data table here. Okay. Are we good? Can I keep going? I'm gonna keep going because nobody's saying anything. All right. So for the post-lab calculations, you can go ahead and scroll down to trial 2 and cross that out because we're not doing anything with trial 2. If you were doing the lab in class, you would have actually done a second trial. But for right now, you're not doing a second trial. You're only doing one trial. Okay. So let's scroll back up. So I went ahead and I crossed off trial 2. So for trial 1, let's see if there's a way for me to make this a little bit bigger. All right. All right. So for trial number 1, we're going to find the change in temperature of the water. Okay, so the formula that I'm using is right here. So the change in temperature of the water is equal to the final temperature of the water minus the initial temperature of the water. Okay, so delta T is equal to the final temperature of the water, which on my data table is the equilibrium temperature here. So it's 23.5. You have a different number though. Okay, so put in whatever your number is. So the equilibrium temperature is the final temperature. Let me just make a note there. It's the equilibrium. Okay, so the equilibrium temperature is 23.5. And the initial temperature of our water is right up here, so 21.5. All right, so 23.5 minus 21.5 is just 2. All right, and this is mine. This is my data. Actually, let me be more specific. This is 2 degrees Celsius. You would do this with your data set, okay? And then let me slide over to the metal. So the metal, you're doing the exact same thing. You're taking the final temperature of the metal, which again, this is the equilibrium temperature. Okay, so the equilibrium temperature is 23.5. We're going to subtract the initial temperature of the metal, which is 100. Okay, I think it's probably different on yours. So minus 100. So 23.5 minus 100 on mine is negative 76.5 degrees Celsius. And that got cut off. Okay, so now at this point you have everything you need to finish the calculations. Alright, so I'm going to go down to here. It says specific heat of your unknown metal using that equation. Alright, so if you watch the video for today, this C right here is what we're trying to find. Okay, the specific heat of the metal. We don't know what that is, but we know everything else in this equation. Alright, so let's start to fill in what we've got. And again, this is this is going to be different for everybody. Everybody has their own set of data. So I'm using my numbers. Please do not use my numbers in your lab, okay? Because I know who's got which unknown, and I'm going to match them up when I go to grade it, okay? Okay, so the mass of our water. So I'm going to start filling in the left side of my equation. Okay, so I'm filling in the left side, and then I'm going to do the right side. Okay, so for the left side of my equation, the mass of my water is 100 grams. I'm going to leave the units off this for right now. So 100 grams is the mass of my water. 4.18 is going to be my specific heat of water. That's going to be the same for everybody. Water always has the same specific heat. And then I'm going to multiply it by the change in temperature. Okay, the change in temperature for the water is what we solved up here. Okay, so this value right here is our change in temperature of the water. And so 2 degrees. All right, so that is the left side. Now I'm going to set that equal. So that's the left side. Let's set that equal to the right side. Okay, now if you look in the equation, there is a negative outside. Okay, I'm going to include that negative. So there's a negative here. It's negative because the metal is exothermic. It's releasing the heat energy into the water. Okay, so exothermic releases energy. It's got that negative sign. Endothermic absorbs that energy, so it has a positive. All right, so our mass of the metal, my mass of the metal was 12.1 grams. I do not know the specific heat, so that'll be C. And then I multiply that by the change in temperature of the metal. So we solved for that right here. That was the second delta T that we solved for, so it's right here. So that number gets plugged in down in the equation here. So times negative 76.5. Okay. Now before we do anything on our calculator, let's make this a little bit easier on ourselves. I want you to notice that we have a negative here and we have a negative here. Okay, so when we do that, we are going to get a positive number. Okay, so we do the inside of the parentheses first. You're going to end up with a positive number. All right, let's keep going. So at this point, you can multiply out the left side of the equation and you can get a number. So when I did it on mine for the left side, the water side, I got 836. When I did the right side, when I did my 12.1 times 76.5, I got 925.65. So I'm multiplying my 12.1 by the 76.5. Okay, so when I multiply those two numbers together, I got 925.65. And then remember, we still have our specific heat in there, our variable. So it's going to be 925.65 times our variable C. Okay. To get our C by itself, we are going to divide both sides by this number, the 925.65. Okay, so this will cancel out. So on mine, 836 divided by 925.65 gives me a C value, a specific heat value of 0.903. Okay, and the units for specific heat are joules over grams degrees Celsius. Oops, and you can't see that. Okay, what questions do you have before I move on? Anybody get lost in the math? I know there's a lot going on, so before I go any further, I want to make sure we're all good. That's fantastic. We have cat's litter boxes in this room, and my cat is going in there to probably go poo-poo, and it's going to smell fantastic in here. Yep, there it goes. It's great. Really? Right now? Cats. Can't you be like a dog and go outside? Alright, did I lose anybody on the math? Alright. Don't see any questions. Maybe you guys are trying to catch up. If you are, that's fine. The next part is not too bad. You're just going to take your number and you're going to look at the table down at the bottom. Okay, so my specific heat value was 0.903. So if I scroll down to this table here, let me rewrite that number, 0.903. That's my specific heat value. And if you look at the table, I have an exact match right here with aluminum. So aluminum has an exact match for my number. Okay. Now, if I didn't get an exact match, if it wasn't exactly 0.903, I would want to select which one was the closest. So let's say it was like 0.908, for example. Asia, why do you hate it here? Yes, the equilibrium temperature is the final temperature. So remember, you've got the metal, which has a higher temperature, and you've got your water, which has a lower temperature. The metal transfers its heat to the water, and the water absorbs the heat from the metal, so they kind of do this, and then when they meet in the middle, the temperatures are the same. That's the equilibrium temperature. So for both the metal and the water, the final temperature is the equilibrium temperature. Yeah, I get that you're overwhelmed. We're all overwhelmed, even us teachers. We don't know what to do. We don't know how long this is going to go on for. So tomorrow morning, I'm actually meeting with the other physics teachers. We're having a virtual meeting. We're Skyping together to try to figure out what to do the next unit because if you think about it, we are both chemistry and physics are both lab courses, and if we're not physically in the building, how do we do labs? I mean, I kind of videotaped one lab for chemistry. That worked okay this time, but for some of the other stuff, it's not quite the same. So we're trying to give you like as close to a genuine experience as we can with what we've got. So we're kind of all trying to figure things out right now. All right. I will say this though, you guys are lucky to be in the district that you are, because like my kids are in a different district and they don't have computers. So the teachers just kind of gave them like packets to work on with some really general instructions, whereas like we can actually kind of still kind of have class. Everybody's got a computer. Everybody has the potential to log in and do stuff. So that's really cool, and you guys are really lucky. So back to the lab. All you need to do once you get your number is look at the table and match up the value that you got to... Okay, so Denasia doesn't know where to place the numbers. We'll go through that in just a second. So once you get your value, once you get your specific heat, you just match it up in the table. That's it. That's all you got to do. All right? And that's all you need to do for today. So let me go back up and backtrack a little bit here. Maybe I can split screen this so you can see both. Let me pull up the data and... All right, let's see if I can do this. Look at this. Like, I'm like a pro here right now. All right. All right. So, Denasia, your question was you don't know where to put stuff. So, on the data table, and let me actually use your data. Okay, so you are this one right here. Okay, so Denasia, if you look at the data table here, I'm going to erase my numbers here and I'll start to fill in yours. Okay, so the M metal is the mass of the metal, so yours is 15.5. And then if you go over, the mass of the water is 100. All right, the specific heat of the water is here if you need it, but it's going to be the same for everybody. There's nowhere to fill that in on the data table. The initial temperature of the metal is 98. So the metal is 98. And then the initial temperature of the water is 21. And then the equilibrium temperature, the very last part, is 23.5. All right, did that help? So if you need to, I'm gonna post this video on YouTube when I'm all done when we're done recording, and if you have questions, you can maybe go back to when I worked through it, so you know how to plug everything in. All right. Any other questions? Can you do mine? Sure, Grace. I will absolutely go through and do yours. All right, just because you're here. So let's see, Grace, you're in 8th period, so let me go back here. All right, so Grace, you're right here. Oops. Come on. All right, so let's go through this. So mass of the metal is, let's see, for yours it was 51. And then the mass of the water was 100. The C value you don't need to put in your data table. And then the initial temperature of the metal. I guess I should have maybe flipped the order of these on the data table, but oh well. The mass of the metal, or sorry, the initial temperature of the metal was 98. And then the initial temperature of the water was 19. And then the final equilibrium temperature was 23. Got it? Anybody else have any other questions about what you need to do today? The calculations. As far as the lab goes for today, just write in on the lab. There's nothing you need to add at the end of the document. Just go ahead and write it in the lab. Okay. There were a lot of questions yesterday about where to put the background information. So I think we've cleared that up now. But for the calculations, just go ahead and write right in the lab document. You can type them if you need to, if you don't have your stylus. But if you just put it in the actual section, that's fine. Okay. Any other questions about the lab? Anybody got anything, any fun plans this afternoon while we're on quarantine? Put this back up. Anybody have any fun plans? Denasia, I know you said you're working. Are they doing anything special at your work with the possibility that you might encounter people that have it, or even worried about you guys contaminating the food? Because there are supposedly the biggest issue with everything is that people that are contagious don't show symptoms, so they're really concerned about that right now. So I'm just curious, maybe since you're working at a restaurant, are they doing anything special out of the normal to protect you guys and to protect the customers? So distracting having cats in here. I don't know what to do with them. Janasia, do you want a cat? Right. No, I get that you're just doing the drive-through, but do you have to like wear masks or gloves? Because you know, when you're really close to the window, I mean, I don't know. And you're handing people food. Are they doing anything special? American Idol, mine too. Then Isabel, you are so late to the party. But I can do yours really quick. I don't know why. I mean, you're just basically just reading the numbers off, but I got you. So, Isabel, you are in 7th period. To wash your hands every 30 minutes. That's good. Practice. I feel like you guys should probably do that anyway, but let's see, Isabel. All right, so you are right here. All right, so let's go through yours. Grills, you have to use gloves. Yeah. Oof, that's not comfortable. Because like when I wear gloves and we do labs in class, my hands get all sweaty and it's nasty. So I'm sure that's not fun because the grill's really hot and you're probably sweating anyway, right? Okay, so Isabel, you wanted me to go through and put yours in. So let's see. The mass of the metal is on yours 37. The mass of the water is 100. And then the water temperature is 21.5. The temperature of the metal was 99. And then the equilibrium temperature was 24. I'm sure that's what you got, right? Do you share the headsets with other people too? You got it, Isabel? I don't think there's so much misinformation out about it. I don't know what to really take as the truth right now. You don't want a cat. Cats are the best. They just kind of do their own thing. You don't have to take them out to go to the bathroom. But then, while you're live streaming, you got cats going poop. Should probably put the kitty litter containers in a different room. But we have dogs and they fight, and we have to keep them in a room where we can close the door sometimes. Yeah. All right. Well, if you guys don't have any other questions, I just want to let you know that all you need to do today, if you didn't do the background information, obviously yesterday, do the background information today. I flipped through and only about half of you had the background information done. So, yeah. Grace, you can't get behind on homework for all this time. So, Janasia, I can go through the calculations with you again in a minute here, but I just want to wrap up because I'm sure not everybody wants to stick around. So work through the lab calculations today. If you're not done with the background information, do the background information. If you were not here yesterday for the live stream, I did go through every single one of the background questions. So if you weren't here yesterday, you can just go through the live stream from yesterday. Just skip ahead, obviously, because the first half of the live stream was physics. But I do go through every single one of the questions and give you the answers, basically. So just kind of summarize it in your own words and then put it at the end of the lab document. So again, let me pull this up. Oops, that's not it. So let me just pull one up here. For the background information, at the very end of your lab document, I accidentally drew on everybody's. I didn't realize it was doing that at the time, but there's a red box at the very end. I want you to just go ahead and put your stuff in there, okay? You're behind, but not in this class. That's awesome. You have a test today. In which class? Oh, man. What kind of teacher gives a test? I'm giving a test in physics next week. Oh, sorry, not next week, the week after. Saida, why isn't your OneNote syncing? Did you try restarting your computer? That's probably the problem. Well, just to wrap up here, I just want to remind you tomorrow, a good friend of mine is going to be joining us, Dr. Sarah Perry. She's a chemistry teacher at the University of Massachusetts. I'm sure you're tired of me reminding you, but it should be a lot of fun. She's going to jump in. She's going to be here for an hour tomorrow. So if you are normally on at 1:30, if you want to jump in at 1 tomorrow, stick around. So she's going to be talking about college level chemistry and any questions you guys have about college level chemistry. So like, what's it like? How does it compare to high school chemistry? She does make stuff. She was bragging that she's the kind of chemist that actually gets to make cool things, not drugs, but she does make cool things. So that would be fun to ask her about. Her experience going through chemistry. So whatever questions you guys have, bring those tomorrow. I did send you an email yesterday with a form you guys can go fill out with questions to ask her in advance. I'm trying to put those together in a list so that way I can just kind of go through them. We kind of have some sort of an order rather than having her jump around with different questions. But if you can't think of any questions in advance, just bring them tomorrow. You can just type them in the chat and she'll be able to see those. Okay? So, Denasia, you said you had trouble with the math. That's all I had for you guys today. If you want to stick around, I'm going to go through the math again with Denasia. Otherwise, I will see you tomorrow at 1 o'clock with Dr. Perry. So let me go back to the math for Denasia. All right. All right, Denasia, what did I just go too fast when I went through it before? Do you want to go through the, I guess, where are you stuck on the calculations? Denasia, are you there? Denasia, I don't know what happened. Maybe you're just typing. The part after you filled in the data table. Adeline, don't worry about the methodology. Okay. I pretty much, at this point, just want you to work on the background information and the math. Okay. I may modify what you have to do because I basically gave you the methodology. So, and we're also, as chemistry teachers, just trying to figure out what we're supposed to even do with this lab. That's why I haven't just given you all to do it. Haven't given it to you all in one piece to just kind of go run with. So I'm just trying to break it into chunks, manageable chunks for you guys right now. All right. So let me go through the calculations really quick, and then we'll wrap up here. So for Denasia, yeah, there's a little bit of a delay, Grace. It's like 10 seconds, it seems like. All right, so really quick with the calculations, I'm not going to go through and redo everything I just talked about, but let me just kind of show you what you're plugging in here. I did go through the entire process with my data, so if you want to go back and rewatch the video, when I'm done here, it'll post to YouTube, and you can do that. But let me just kind of show you what you're plugging in. All right. J-Lo, it's good to see you. All right. On the calculations, the initial temperature of the water right here and the equilibrium temperature, which is kind of like the final temperature, is what you're going to use for this first part right here, okay, for down here. So that's for the water, all right? So the initial temperature of the water and the final temperature. So you're just plugging into those formulas, all right? The second part, where we do the metal is the initial temperature of the metal and the equilibrium temperature, which is the final temperature as well, okay? That gets used right here. All right, and then once you have all of that, you're going to plug into the formula. Okay, so the formula is down here at the bottom. I'm looking at this right here. So the mass, let me see if I can maybe color code this for you. So the mass of the water is this right here. Then the specific heat, the C value right here. C equals, hey Omar, 4 point something, I don't remember what it is, 4.18. 4.18 is the C value. Your T, the temperature of the water, the final temperature of the water comes from this right here. All right. And then the other side, the mass of the water, sorry, the mass of the metal comes from up here. The C value is what we're trying to find, and then the T, the temperature, let's see if I can get a different color. The temperature of the metal, this right here, comes from this. So whatever you solved for up there goes right there. Okay, and then the C, this is what we're trying to find. Okay, so again, if you came in late or you missed me going through the calculations, I'm going to post this on YouTube in a couple minutes, and you'll be able to go back and watch them again. But that C value is what we're trying to find. Okay, so I go through how to do the math after that point, but that's where all the pieces come from. So, Denasia, if you're still having trouble, please shoot me an email, and if you're doing it in OneNote, I can actually pull up your OneNote and look at it, see where maybe you're getting stuck. So just do the best you can to try to do it on your own, and then we'll go from there. All right, so with that, I just want to, one more time, just I'm going to keep plugging this. I want to see all of you guys tomorrow. We've got Dr. Perry coming at 1 o'clock tomorrow to talk to you guys about college chemistry, ask her questions about chemistry, like what's the coolest thing she's ever made, did she play with acids, you know, all that kind of cool stuff. All right, so I will see you guys tomorrow. Enjoy the rest of your